Hey everyone, I'm going to explain InteractorAI. It is a new feature that comes with Interactor 0.95 and it allows your players to interact with object without needing to go nearby of those objects, without having to stay in correct positions with correct rotations. So it will take control of your character and it will go to interactions by itself. So this issue is pretty common in gaming, especially in old games. So let me mute this. So we have our player here. It is going to interact with the button. When it interacts, as you can see, it lerps the character to correct position because animation is corrected for this position and for this rotation. It is also still popular in today's games, but mostly some modern games especially fixes those problems. He is having some problems with door. Over here, this is Last of Us 2. It is one of the most advanced in terms of technicality games today, in my opinion. So this character also interacts with the door. Normally it runs. The player moves around by running. But here the character walks to the door. Because it is the game itself moves to player to interaction. So it can be seen over here. This is behind the scenes. It is the development tools. So as you can see, when the player interacts, the character goes by itself to interactions. If it is too far away, if it is not in a good position, maybe some wrong angles. So this is what we are going to do with Interactor. So actually, InteractorAI has that purpose. Sometimes it goes different positions. Also, they have lots of animations to support that as well, which is also one of my goals, to add some supporting animations. But right now we have InteractorAI, and let me show you. Here we have a handset interaction in front of us. Normally we need to go to interaction position, but now we don't need to do that. I am pressing E and the player goes by itself and interacts with the phone. If I'm on a different rotation and different position, I'm pressing and it again goes to location and interacts. Also, we have another cool feature here. Since we are at it, let's select our payphone handset. So we have a start early option here, which allows us to start interaction earlier. This is in meters, this is a distance. So this way you can have more smooth and natural interactions. So I'm going to put a 0.55. So it means start the interaction 55 centimeters earlier from the interaction object. So it will allow us more natural interaction. As you can see, it doesn't need to go and full stop and then start interaction. It can just start the interaction right before. So it is more, I think it is a lot better in my opinion. So also I took it a bit further and made this InteractorAI a fully working pathfinding solution as well. So you can see I have lots of interactions here, and that's because I have a grid object here, and it created a walkable mask, walkable areas for me on the start of the game. And right now it knows where the player can walk and where it can't walk. As you can see, it shows these areas. So this way I can move anywhere in this grid, And this grid is also adds all the interactions. So as you can see, I have all the interactions here available for me. So I can select any of them, and it will just go to there. So not you don't need to be near your object here. You can interact on larger areas, and it works pretty well. So if you have a room full of interactions and you want your players to select any of them, so this is how you can do. And this is the creation process of this grid is only takes 3 or 4 milliseconds in the start. It is actually pretty fast. It is just 1 frame and 3 or 4 milliseconds depending on your GPU as well. Also, it is depending on your grid size. This is actually pretty big grid, and I can also walk. I can also run as well. Yeah, this is a really big grid. So it has 14 by 14. Let me see. It has 4,900 nodes on it. So it is all little squares. I will explain them. So even that, it works. It creates really fast, and you can, as you can see, you can interact with anything. Let's use the TV. It also calculates the camera rotations as well. So it can move your character. Let me select another one. What do we have else? While you are changing your camera direction. So this is a controller with a camera relative direction. So the player forward is always changing with the camera direction. So I am pressing F. So this is going this way. If I look this way, when I press F, it goes to camera forward, right? So this InteractorAI knows that, and it is calculating the correct directions. So also this InteractorAI supports moving objects, moving colliders as well. So I have another place here. So as you can see, it have some moving objects here, and the path is actually closed here. Also, this is another debug view. It instead of red areas, where is it? It is showing. Sorry. It is showing more detailed. There are also proximity areas that player can walk but not prefer. So it won't stick to walls or objects when rotating around them. So let's unblock the path first. Let me run. Now it will move the object and the path will be open. It is opened. So actually there is two interaction. So this interaction is actually on the two grids. So it doesn't show that. And then when we walk, it updates, and it is going to claim the price. So it updates. This update time is really depend on you, and also the movement speed is an important factor as well here. The character's movement speed or the object's movement speed and the update time. If we increase the update time, it will update faster, so the player doesn't need to rotate around itself. And if we also run, again, it won't stuck to the objects because now it has more time. It is going more faster. Hang on. Let me also increase the update time here. So this is all optimization. I have here on my object, I have an update time of half a second. Now let's increase that 0.1. Now it will update when we interact faster. Let's try. Now it is avoiding objects faster. So it is up to you, right? You can update. If you have less objects, you can update faster without any cost. And if you have faster moving colliders around you, you can adjust your settings. So we have another one here. So I have basic bots as example. I have a call bot interaction here. It is actually an empty interaction. It will just use its hand to call the bots, but the bots actually will be called because we are entered this next grid, right? So this grid fires these other interactors. There are 10 interactors here, tries to follow us, and they are all pathfinding simultaneously over here. Some of them are actually stuck because this bot controller pretty basic. It is just trying to go forward. So if you have more advanced AI, they will behave better. So in the performance based, it is actually nothing. We are right now on 3 to 2 milliseconds, and these guys are all try to find path simultaneously. Let's try again over here. They are trying to reach us because we are the interactor object here. The character, my Unity armature, has a interactor object on it, and they will try to interact with us. So they are trying to reach to us. So you can create some other gameplay with your creativity. It is up to you. Okay, so let me try to explain how it works, how you can use it. To do that, let me just go to a new empty scene. So we have only one interaction here, and we don't have anything else. So this is all empty, and we can interact with this object in old way. So we have to go to the correct position, correct spot here. It can't go to object by itself, and we need to stay on the correct position. So we have three main components in InteractorAI. First of all, you need a pathfinder. So let's create an empty object here. It can be on the 0 point. It doesn't matter actually. You need only one pathfinder in the scene, but you definitely need one. It can create by itself. There is no pathfinder, but it will take some time. So it is better to have a pathfinder in your scene. Okay, we have no settings on it. It will just process all the pathfinding operations in the scene. And then let's create another one. So this will be our grid object. So it will define the borders for our grid. So this PathGrid, as I said before, you can set its boundaries. It can be big, it can be small, it doesn't matter. The big, actually it matters, but the bigger will be slower than the small grids, right? So, but it is overall working pretty fast. Let's adjust its size. Let's say we have a really small one, 5 by 5. Once you create it, you need to reposition your grid, because in the game, in the runtime, you can't reposition your grid. It will be static. So let's place it here. You can add interaction objects, and the interactors that enters this grid's trigger can run in runtime, and you can remove your interactions from grid. That's no problem, but you can't move the grid. And then we need to set the player layer. So this way it will know, it will eliminate all the colliders enters its grid. It has a built-in box collider here, and it will adjust its size to the borders, and it will know, it will work as a trigger. If I press start, as you can see, it adjusted its size. So once the player with InteractorAI enters this trigger, it will know, and it will start the interactions. It will add the interactions to this interactor. So we need to select the player layer here, the layer we have interactor on. and then we need to select ignore mask. So this will look in this ground, and it will check these positions one by one. It is a really fast check. It is a capsule check, and it is one of the fastest physics check in Unity. So we need to add some objects to the layers that we don't want to collide. For example, the floor object, right? Because we don't want the collide with the floor, otherwise all the places will be unwalkable. So there is another layer unit. I call it ignore mask. You can have it any layer you have, but you need a layer, and you need to assign the objects that you don't want to collide to that layer. So in this case, this floor object is on the ignore mask, and I will say this PathGrid ignore the ignore mask layer objects, and also ignore the player as well, because player can be on this grid, and player also have colliders. So we don't want to set the player position as unwalkable. So I will select these two layers. I have selected my size, and we can skip this one. There's a trigger height here. So as you can see, that when the grid initiates, it also creates extra height. So this is because when you have sloped terrain, you can still enter this trigger. Let's say you have a terrain like this, right? And you want to enter this trigger as well. So you can increase the extra trigger height by maybe 10. So this way, players still enter this trigger. And then let's go back. Let's call this PathGrid. By the way, you can have multiple grids, and you can have these grids intersect with each other. That's no problem. And now the one of the most important settings here, node radius. You can leave it 0.0, it works well. This means the grid parts it needs to check. So the the lower node radius means the more resolution you will have for your objects. First of all, let me disable this lazy initiation, and let's put here 1. Over here we can see these all walkable, because these nodes are too big, and it will just check. It created 4 nodes, and it checked these 4 locations, and since they are empty, it is decided to all walkable. And if we change that, let's lower the grid nodes. Let's give him 0.5. Now it created 25 nodes, and now it has some colliding objects here. Also, we can select the detailed debug here. So these are the nodes here, and the red ones are unwalkables. The gray ones are the avoiding but walkable, and the empty ones are 100% walkable. So let's also lower this node radius to 0.1, and I'm going to reinitiate here. I can come over here and reinitialize the grid over here. Now we have a lot more resolution here, but right now we have 625 nodes. So it is, again, as I said, it is pretty fast. These numbers are rookie numbers. You can pump those numbers up really high. So as long as 10,000, it is okay. Even 10,000 and 20,000 are okay too. But it will take 4 and 5 milliseconds on start when it is creating the grid. And you can also have lazy initiation here. If you select this, let's say you have lots of grid in your same scene, and you don't want them to initiate at the same time on start. You can have them initiate only when player enters one of them. So it is created. Actually, it is not created because we don't have InteractorAI on our object. but we will have. Okay, this lazy initiation is pretty useful for that. Let's go. We have also player radius. So it is radius. Don't forget, it is not a diameter. It is only the half size of your width. So it also plays a crucial role when you create your grid, because let me just lower this one first. 0.1 is good. Initiate. So we can go to this position, for example, right? But since our width is a lot larger, we will collide with the object if we go to this position. So that means if you increase your radius, it will also increase the areas of the colliding objects. Let's try again. As you can see, now the walkable areas are a lot less because we set our player radius as 1, which means our player is 2 by 2 big. So that means player can't go closer than this, otherwise it will collide. So it is calculating that. So that's why this player radius needs to be accurate as your player. So how can you see your player radius? It is usually the capsule colliders on your player, right? The colliding object, and it has a radius here. It is 0.18. But to make sure, I'm usually using 0.2 or 0.25. So I don't get close with the objects. But also it is lowers the positions when you want to walk around. Also we have player height as well, and still it is on the capsule collider. You can give same height, or you can, if you don't know your height, you can maybe calculate with the interactor target. It can be useful. Let me search for, actually we can go here, open our spanner window. Let's create here a target here. Okay. Let's create a target here. Now I think it is also added some interaction. Yeah. So this, if we leave this object on the ground on 0 position, you can put it right bottom of your character, and you can find your path, and you can place it on your head like this. So it is pretty much the same length. So you can see the length over here. It is actually 1.78. That's another way to calculate some distance in your game. So this is pretty accurate. You can use to measure things in your scene. So yeah, the player length is, since it is going to check all the nodes with capsules, it will check the capsule exactly the same one that we have. So it can know which objects that you can walk under as well, this way, if you give the correct height. But the height calculation, unfortunately, will be made with the grid position height. So if you have a terrain with slope, that means it is not going to calculate your height on different locations. It will only calculate from the grid's position. Okay, don't forget that. And next one, we have step height, but in this case you can increase your step. Step height means that the objects that your player can walk through, some small steps or bigger steps depending on your character. So you can give your step height here. So let me quickly show this. Let's say we have an object in the ground, right? Normally we can walk on this object, so we can give it accurate step height. Otherwise it will set it as a unwalkable space. So as you can see, it is not looking accurate. That's because we have a low resolution here. If we increase the resolution, we forgot that. We initiate. Now it has accurate resolution. And it is marked this area as unwalkable because the step height is lower than this object's height. So this is higher than the 0.02. So if we give a bigger value and reinitiate, now it is walkable. You can use this feature for sloped terrains. Okay, this needs to be 0 because our controller here is pretty basic. It comes with the one Unity examples, and it can't walk even smaller steps. So we leave it as 0. And then we have a proximity penalty. So this is also another important one. As I told you earlier, we have proximity grounds. Okay, hang on, let's go to a detailed one. So this proximity ground right now is count as 1, and it is creating only 1 node per unwalkable node. It means, okay, you can walk on these nodes, but you will prefer, the Pathfinder algorithm will prefer the empty nodes if it is same length. So the pathfinding process based on 2 things. We don't have InteractorAI now. If the path is, the alternative empty path is too long, it can still walk on these proximity grounds. So if you give higher proximity, it will select the longer way with empty nodes. Actually, I can show it here real quick. Here we have, let's move this player right here. So I will go to interact with this coffee cart, and there's an empty spot here. Okay, so if I press play, let's go to detailed, and let's close the moving objects debug. Okay, as you can see, there's a spot here as walkable. It is a proximity penalty, but still it is walkable. So if I select the interact with the object, it avoids that path even the alternative is longer, right? So that's because I have a proximity penalty of 50. So let's try this one with a lower value, and let's see what happens. So I said it is 10. Right now it is choosing that other path. But as you can see, it is a bit risky here. It can collide with the objects because this is too narrow. So that's why these proximity grounds are pretty useful. You can lower, it all depends on your layout, on the scene, in your grid. And so we have lots of spaces here, for example. And since we have low proximity, it will always choose the shortest path. Mostly, I mean. So let's go to handset again. So it chooses here. Actually, it needs to choose because there's no empty node to go there, right? So if we delete this, let's reinitiate real quick. Now it has an empty spot as alternative. So if I select handset again, it is still choosing this path. But now I can increase the proximity to maybe 100. Let's reinitialize. Let's retry. Now it is, as you can see, choosing the alternative because we give so much penalty to proximity. It still can go if this object is, if the alternative road is too long. Maybe this object is here and this object is not here. Let's reinitialize. Now it is a bit longer, not long enough. Let's put some other objects as well. So maybe it is really far away, right? Let's reinitialize the grid. Okay, we need an empty spot here. So maybe we can move this a bit further. Initialize. Yeah, now okay, we have empty spot. Let's see if it is going to select that. It is not selecting, as you can see, because it is too far away. It will cost too much, much more than this penalty, this single node penalty, right? I can still make him go to that path. If I increase the penalty cost too much, maybe 2,500. No, okay, it's actually found a shorter path here. Makes sense. Yeah, it is. That means it is shorter. Okay. All right, that's how it works. So you can adjust all these values, all depending on your layout. Okay. So I explained most of the stuff here. So the thing you should know, the PathGrid InteractorAI interactions needs to be on this grid. So you need to add the interaction to here. So this way, when player enters, these interactions will be automatically added to player, and it will be selectable, or it depends on your game structure as well. Maybe you can show them E button on each one of them. And we have also moving colliders. So this system also supports the moving colliders, so it can update the grid walkable areas. This is also pretty optimized. It will only update the grid, the objects collider bounds. So let's see, how can I do that? Now, first of all, we need to add InteractorAI to our object, to our player. Let's add it. Hang on. So this is the third component. So we need Pathfinder, we need PathGrid with added interactions on it. Okay, you need to adjust the settings, and then we need InteractorAI on the player object. Now we can see our changes, and it will create the grid. If we select lazy initiation, it will create the grid when we enter. Or here. So let's see. So let's say I want this object to move. But first, we need to. I need to mention one more thing. So we added this interaction to the grid, right? It is on the grid, handset InteractorObject. But we didn't set any settings on the InteractorObject. We also have a few settings. This is a new section on InteractorObjects as AI settings. So to enable this object's AI option, you need to assign a transform. So this transform will be the position and the rotation that player will go. It can be any transform. You don't need to create a new one, but you can create as well, because it is just an empty object. It doesn't cost anything. So I usually put them on the ground. Let's call it a handset AI target. And I place them on the object. So when I move the object, they will also move. And so this object's rotation really matters, because the forward will be your player's forward. But you need to be on local. Don't forget that. So I am going to change it to look to phone booth. So let's say we want to interact with this object right around here. Height doesn't matter, but the X and Z define your position, and their directions define your rotation. So right now, this interactor object, when you set your transform, it is enabled. That's all you need to do. You can set it AI only. So this way, the interactor object only can be interacted with InteractorAI. Even if you are standing in a good position, the character will go to your predesignated area. Okay, if you select this. So it can be also useful for some specific conditions. And there is also start early. You know this. It is going to start earlier. But there's one more thing. When interactor path finds to the object, sometimes there is not enough space to adjust the rotation. So the final rotation may be different with your AI target. Let me show you real quick. Actually, I can't show because we didn't set the InteractorAI settings. Okay, I'm gonna move my character by myself. What is the center? So let's say you use this object. InteractorAI took this character, but it couldn't adjust its rotation. Come on. I said this is a basic controller, so it goes crazy. Okay, that's why. So maybe it couldn't manage to adjust its rotation. So that means your character needs to go around again. It can't start the interaction if it is too different. If your pre-adjusted rotation is too different than your final position. So in this case, you can actually say start early with a small difference. So this way it will eliminate those small differences. That is also useful for that. Okay, let's continue. Now the final component, InteractorAI, some settings on it, has some settings. And first of all, one of them is Interactor. It is by just itself. You can put your character here. And you need your transform, play transform. It needs to be parent object. And then you need your pathfinder in the scene. It can find all these objects. Even it can create the pathfinder, but as I told you earlier, it is best to keep these set before. So now you need to select your controller schema. I will talk about the integration of this system. It is a 1 or 2 line script, and I will show the integration with different assets on the asset store, like Interactor or some others. It is not hard. It is really easy thing to do, but it will be different video. So let's say you did that, and then you need to select your controller schema. So this is 2-axis cam. It means our character move with horizontal and vertical axes, and we have a camera sets our direction, right? For most 3D games, third-person games uses these settings, but some of them can use 2-axis, which means it won't use camera direction. The player always goes its forward, even the camera is rotated different angle. It will always go this direction in some games. If it is your controller, you can select 2-axis, but if your forward direction changes with the camera direction, then you need to select this one. Or some games uses the forward button instead of analog sticks. So this that means your player speed can't adjust it, and it means you can go forward with W button or some forward button in your gamepad, right? This is mostly used in first-person games. So when you press, player moves. That's all. It is all simple. You can select this option as well. And if you don't want to set a button, you can use the string. So if your player inputs are configurable, you can still say set your forward input name, and InteractorAI will get that. And there's also AI. For the AI, you need to dive into codes and get the forward and rotation from InteractorAI. So it needs a bit of scripting. Maybe you can do it with events as well. I don't know. I'm not sure. But on InteractorAI, over here, so you have these public access functions. So it will calculate the forward This means it will go forward, and it will calculate the rotation. It can give you angle, or it can give you the final rotation. Which one of you works for you, for your AI characters? So there is an example on the bot script. It is pretty easy. It is pretty basic bots. Let me show you that as well. So this is basic bot. That's why they are stuck earlier. So they just go to forward, and they just try to rotate, and they get those values from InteractorAI. So this means this is just a bool, go forward, and then this is just a rotation, and it is going to get the rotation from InteractorAI. Get yaw. This is the angle it needs to change per frame, or it can get the rotation as well by this transform rotation InteractorAI get rotation. This also works. So InteractorAI sets the forward vector, sets the forward, true or false, and the rotation. That's all. So you can easily implement in your AI. Okay, let's move on. And what else do we have? So we will select your cam. If you select cam, you need to assign your camera as well. It can get the main camera, by the way. And there is also run schema. You can use the running if you have a running button. You can use button here as well as the forward, or you can give the string if you have an input name. By the way, let me show these input names. We have inputs here, right? If you have a running input here, you can call its name here, like fire1, and it will get that button, and it will adjust the running by itself. So this is rotate player directly. It means it will rotate your player transform when it is moving. Okay, that's how it works. Or you can get the rotation from InteractorAI that I showed you before, right now. Otherwise, it needs to rotate the character transform that you assigned here, because the rotation is really tricky. I designed a system that can work with a lot of types of controller, and all controllers work different. So if your controller doesn't allow you to rotate your player transform, and some controllers always reset even if you rotate them. So that means you need to get the rotation from InteractorAI by yourself. Okay, if you can rotate your character, that's no problem, and you can select this. And then there is prevent input option. This will allow, prevent the player input. Otherwise, when you press E, what is this? Hang on. Let me set this as 0. When you press E, oh, come on. What did I miss here? Time distance. Oh, I think it is. Oh, okay, we are getting errors. That's because we selected. Actually, I'm gonna select no running. We didn't set the button here. This is also 0. So when your player presses any button, any movement button, like this, it will stop the pathfinding process, and it will again give control to players. So if you select that, that means player can't stop until it ends. And then we have speed. This speed only works if you have adjustable speed with your controller. If it is compatible with analog sticks, right? If you push analog stick and your character goes slower, that's perfect. You can set your speed here as well. And this is also stopping. This goes for the stopping distance as well. Stopping distance will slow down your character when it closes to interactions. So in this case, I set it as 1 meter. But as I told you earlier, this controller is pretty basic, and it doesn't allow slow speeds. The Unity example controller script here, player controller, it doesn't allow slow speeds. So that's why it is going to get stuck when this stopping distance works. But if you have, the most controllers have that option, so I don't think you will have problems. If you have problems, you can disable it by setting it to 0. Forward start will make your character find its path with forward direction. So this turn speed, if this is low, it means your character will turn really slow. That means it can't make it to the final destination. Okay, that's that means you need to give higher values for turn speed. But if you give too much turn speed, that means your character instantly turn. So you need to adjust it depending on your character. And there's also turn distance. Turn distance means, so there, if you come over here, so as you can see, when we create a path, it also creates lines. So the character actually won't follow this path exactly because it is too robotic, too unnatural if it follows this path. So it is actually starts rotating before reaching to nodes. So that way it can create a smoother path, and these lines actually usually shows actual path. So if you lower this turn distance, let's make it 0, that means all the turning these points will be on nodes, and that also means it will follow the path exactly same way. Okay, I ended the interaction early. Let me put this same spot. So this is actually pretty small area. It will follow and it will turn. Instead of that, we can increase this turn distance. Let me go similar position. And when we find the path, now it will rotate faster. That means it doesn't need to rotate too sharp. And you can make your character slow down when it is rotating, turning, and this is also defines the angle that it will slow down. And you can also disable the running when when rotating. And this is update time. So that's how it works. So if I need to summarize really quick, you need one pathfinder in your scene, only one. You need a PathGrid, as many as you want, and you need to adjust their positions, but their positions can't be changed in runtime. And you need to adjust its settings. And for the interactions you want to use InteractorAI with, you need to set their AI targets. Those targets are can be any transform, but it will define the position and rotation that your character will go to interact. And once they have that transform, the AI interactor for them will be enabled. And then they can be added to the grid you created. You can have as many as interactor objects on your grid, and you can have as many colliders, moving colliders as well. They will be updated in the runtime when you find your path. But the more moving colliders means the more area will be updated. So it will cost you more. It is not much. It is not like creating a grid, but it will cost more. So you should just know that. And once you set your grid, we set our two components. The final component will be InteractorAI, which is going to be on your player object with Interactor. So you assign your settings, you set your controller schema, and adjust your speeds, rotates, and you are good to go. But also there is one more thing, the final thing, the integration. So it will be explained in integrations video. and there will be examples for different controllers. But in short, it is only one line, 2 lines of code. That's all. So if you have let's say you have an input script here. Normally, you will get your axis. If I explain it shortly here. Close this. So normally you use input get axis horizontal for getting the horizontal, right? So instead of that, you will use InteractorAI input get axis. That's all. If you have 2 axis controller, then you can use it on both axes. It will work as same as the input get axis without any cost, without any performance. And when you use your path, it will take control and it will set its inputs by itself. I mean the InteractorAI. Also, if you are using the running button as well, so we have a run button here. Where is run? Run. Come on, run. Run. Oh, get run. We don't have run. Oh, okay, it is get shift. Sorry. Okay, this is our run button. It is normally uses the input get key code left shift. So we can say InteractorAI input get key. So InteractorAI lots of functions for the user, for you. So you can use get axis role. You can use get key, get button, and that's all. So it will satisfy all the needs. So if this is for the running, but if you want to use the running, you will just replace one line of code, and you will set your input names on your InteractorAI here. That's all. That's for the integrations, and I will show those integrations for different kind of controllers. And I hope you like this. I think that's all about it, and see you on the next one. Thank you.